Hello students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the third lecture on solution. In the previous two lectures, what we have discussed, first let us understand. In the first lecture, we have discussed about the very fundamental things, that is what is solutions, type of the solutions and different ways how we can able to express the concentration of the solutions. Very simple thing. In the second lecture we have discussed about some numerical touch, right? The relationship between some important parameters like mole fraction of the solute and the molarity, mole fraction of the solute with the molality, and the relationship between the morality and molality that we have discussed. And also we have discussed when we are going to mix two different solutions having the different normality, morality, and when we mix it, what will be the resultant your normality or morality, that we have also discussed in those videos. If you have not watched this video, you should watch this, and that will be beneficial for clarity of your concept in the solution chapter. In this third lecture, what we are going to discuss, that is the solubility of the solid solute in the liquid solvent. So, heading of this today's lecture, this is lecture number 3, and heading of lecture is solubility of solid solute. It will going to produce the liquid solution. That we have understand that liquid solution can be prepared with the help of the solid solute, with the help of gaseous solute, and with help of the liquid solute. So here we will be going to discuss the solubility of the solid solute in the liquid solvent. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. When we put some solid solute in a liquid solvent, and of course this solid solute must be soluble in that liquid, because we know all the solid solute will not be dissolved in every given liquids. There is a criteria that we will also discuss, that is what are the factors which is going to influence the solubility of the solid solids. So when we add some, suppose as example sugar, it's a very common example that you can see, sugar, that is a sugar solution. When we put some sugar in a container having a water, some of the sugar will be dissolved in it, and with the time what we will see, what we will find, that the concentration of the solution goes on increasing, and this process is called the dissolution. So one process that is we must understand, this is dissolution process. Dissolution means this process, we can say, we can write in the terms of the reaction, dissolution process. It is that when we can write solvent plus solute, solvent plus solute, and it is going to the solution. The example we have taken, that solute is there, solute. This is talking about the solute. The solute will be the solid. So solvent plus solute, it will going to give us the solution. And this is process is called the dissolution process. With the time, what will happen? The solute particle from the solution will strike the solute. Solute particles from the solute will strike the solute, and it will be separated away from the solution. And this is another process that we are going to understand. That is this process is called crystallization. Crystallization. This is a very, very important process. Crystallization. What is going to happen? This is a reverse reaction. We can write solution to solvent plus solute. So when these two processes we add, this is a reverse process and this is the forward process and this is the reverse process. So we can write also in this way also, that is solvent plus solute. Solution. So the solution preparation is composed of the two processes. One dissolution and another is crystallization. And time will come when we will find that the concentration of the solution is become constant, is become fixed. At that time, there is a dynamic equilibrium established in the solution. Dynamic equilibrium. At this stage, what will happen? Going to happen? These two processes, that is dissolution and crystallization, will be rate of the dissolution and rate of the crystallization will be equal. Means the number of particles that leaving the solution phase and number of particles that entering the solution phase will be equal. And at that time, we will call, when this stage has been arrived, we will call this is a saturation point of that solution. Saturation point of that solution, and we call it this solution at this stage as a particular temperature we call the saturated temperature. So next things that we need to understand, that is saturation point. Saturation solution. Saturation solution is such a solution at a particular temperature. We have to always write temperature. A particular temperature we have to write. If temperature changes, then the saturation point of the solution will change. To add temperature in which we can write a solution in which the temperature in which no more solute will be added. No more solute shall be added to the solution. At that time, we will call it a saturation solution. Before that, the position of the condition of the solution we will call unsaturated solution. Unsaturated solution. Unsaturated solution at the temperature in which we can add more water, more solute. We can add more solute. And another stage of the solution that we can artificially create by increasing the temperature, that is called the supersaturated solution. This is called supersaturated solution. And the supersaturated solution, what is there? We can in this solution you will find the more than solute particle, more than solute than the saturation point. Suppose saturation point is having 10 gram of sugar. Suppose in the supersaturated solution you will find that depends on the temperature. If the higher is the temperature, then you will have the higher amount. And this technique is applied when we are preparing the sweets. Sweets has been kept in the supersaturated solution of the sugar solution, and we can observe the thick syrup has been prepared with this. So we understand the solubility, we understand the how a sugar or a solute has been dissolved in a solution, and there is a two process that is when we observe, that is dissolution process and another is crystallization process, and the equilibrium, which is called a dynamic equilibrium. Both these processes become equal, and at this process the number of the solute particles entering and leaving the solution phase is fixed, is constant. And we also want to understand saturation solution and the unsaturated solution. The discussion will be end up with a very vital thing that we are going to discuss now, that is the solubility. That is now what is solubility we now understand. We now understand that at a particular temperature the maximum amount of the solute has been taken up by the solution is called the solubility. So we can write the solubility, we can say solubility of the substance is the maximum amount of the solute in a specified solvent at a particular conditions, temperatures and other conditions, temperature and pressures, is called the solubility of that substance. So we can write the solubility in more specific and more accurate way, quantifying this. We can write solubility, we can write this solubility of substance we can write solubility solubility of substance is the amount in gram dissolved in 100 gram of solvent. In 100 gram of solvent, 100 gram of solvent to produce a saturated solution, to produce a saturated solution at a particular temperature and other conditions. So we understand what is solubility. That is a very, very important thing. Solubility of the solute. It is basically a substance solubility of the substance, and the amount of the substance in gram that has been dissolved in the 100 gram of the solvent at a particular temperature and a particular pressure to produce a saturated solution. We now understand that saturation means the maximum amount of solute that can go to the solution. So you understand this very vital thing in the solubility of solid topic, in the liquid solvent, that we understand. Now the most important thing that is we are going to understand, that is what are the factors that is going to influence that solubility of a solid solute. Because the factors, there are basic different factors that we can understand. Factors, first factors that we will be going to understand, the lattice enthalpy and hydration enthalpy. What is the relationship? What is the lattice enthalpy? We already know in our class 1. So what is lattice enthalpy? In the chemical bonding chapter, you can understand this. And if you have some doubts, you can go to my video in the chemical bonding chapters. I can give you the link here, when we publish at the YouTube channel. So what is the lattice enthalpy and hydration enthalpy? Let us first understand. Lattice enthalpy is the amount of the energy required to dissociate a 1 mole of ionic product into its constituents. It is the amount of the energy required in joule for dissociating 1 mole of the ionic substance into its constituent ions. And hydration enthalpy is the energy evolved when it is hydrated. That we understand, when the ions are being hydrated means it is being surrounded. It means ions are is being attracted by strong electrostatic forces. And when we hydrate it means these ions are being separated. How it is separated? Now this will be first surrounded by the H2O molecules, and these H2 molecules will separate the two ions, that is positive ion and cations, from each other, and it will be separated. It is called hydration. And at that time there is a evolution of the energy, you can see, and this amount of energy to evaluate when there is a process of hydration of the ions on moles of ions, it is called the hydration enthalpy. In the solubility, that is a very important thing. The hydration enthalpy must be greater than the lattice enthalpy. That is the main thing that we can write. Lattice enthalpy is greater than, here you can write the hydration enthalpy. Hydration enthalpy is greater than the lattice enthalpy, then there will be the solubility of this solid substance, otherwise not. There are other points also that we are going to discuss. That is the first, the temperature. Then we will discuss the pressure. We are going to discuss another very important factor, that is temperature. How temperature going to influence the solubility of, that is the solute solubility. How that is going to impact temperature. Temperature is very important factors when we are going to dissolve the solute in the liquid solvent. How it is, let us understand. When we dissolve any solid solute, it is either it is accompanied with the evolution of the energy. We can write this dissolution. We can write this dissolution That is when we dissolve, this dissolution accompanied dissolution accompanied with heat absorption, means we can write it is endothermic reaction. It is endothermic reaction. Endothermic reaction means heat is absorbed. Endothermic. And here enthalpy of solution is positive. Example, suppose NaCl, KCl, KNO3, NaNO3, all those substances, when you are going to dissolve in the water, it will going to absorb energy. That is why this process, dissolution of this substance in the water, is the endothermic. And the another case, this is the case 1. In the case 2, suppose Li2CO3, cerium sulfate, or Na2CO3H2. For this substance, what we observe, this is very important thing to understand. When this substance has been dissolved, it will evolve energy. So when we making this substance dissolve, its process is called the exothermic. And in this exothermic process, the delta H solution will be negative. So both these cases, we will find the different behavior when we increase the temperature. How this behavior? Let us have some graphical representation. In the y-axis, the solubility. In the x-axis is the temperature. Solubility, that is 20, 40, 60 suppose. Now we plot this is when we plot this is the curve. This curve, this is against the temperature and the solubility of the substance, it is called the solubility curve. It is called the solubility curve. When we plot the initial, we will find this curve is like this. What it signifies? It signifies that with the increasing of the temperature, the solubility goes on increasing. Okay, for KNO3, you will find this type of things. This is for initial and this is for KNO3. Okay, now another substance. This is cerium sulfate. Cerium sulfate, it is having, you can see, as we go on increasing the temperature, the solubility goes on decreasing. All the cases you can find whether it is decreasing or increasing, but there are some substances where you will find there is a differentiate. As for example, NaSO4. NaSO4, you will find this type of tendency. Here as a temperature 32 degrees Celsius, what you will find that NaSO4 has Na2SO4, 10H2O. This is the hydrated salt. This one go on increasing the temperature up to 32 degrees Celsius. What we find? There is an increase of solubility as we go on increasing the temperature, as we can see from this graph. But after 32 degrees Celsius, you will find the differentiate. It is increasing. it is decreasing. Why it is so? Because at some point, this is called a transition temperature, at some points there is the changes of the crystal structure. The crystal structure means changes from alpha form to the beta form. What is the structure? That we are going into depth, but this has happened, and that is why there is a behavioral pattern of the solubility of the sodium sulfate. This is highly saturated salt, and when this H2 has been evolved, and it will show a T5 type. Another that we can discuss, that is calcium chloride. Here you can see calcium chloride. It also shows this type of very interesting trend. CaCl2 6H2. This trend you will observe when it is CaCl2 H2 4H2. This trend you will observe, and when it is CaCl2 H2 2H2, you will observe this. So solubility curve goes on a interesting type of curving. You can see initially it is increasing, but in that behavior also there is something that we can very interesting to understand. Here also same thing applied. There is a changes of the crystal structure. So we understand the solubility of how the temperature is going to influence. If it is endothermic, then with increasing the temperature, the solubility will be increases. If it is exothermic, and the solubility will be decreases. And another thing that we will discuss again, the important thing, that is the nature of the third point. First point we have discussed, that is the lattice enthalpy and hydration enthalpy. Second point, that is temperature, and third point, the nature of solute and solvent. Solute and solvent. That is very you may know this. Why it is like that? Now suppose we are ionic solids. Suppose NaCl, KCl, KNO3, NaNO3, all are ionic solids. And these ionic solids will be readily being dissolved in water because it is a polar solvent. But some molecular solids, solid iodine, naphthalene, anthracites, those are molecular solids, and those molecular solids, this is ionic side you can write, and molecular solid. Molecular solid, they are not dissolved in water. They will dissolve in benzene, CCl4, all the things. So it is we can say that all the solid will not going to dissolve in a given liquid. It will depends on its nature. If it is polar, then it will going to dissolve the ionic solids. It is non-polar, it will not going to dissolve in the polar solvent. So that is to be understood. But one thing, why glucose being a non-polar, being a molecular solid, how it is going to dissolve in water? It is because it will probably say hydrogen bonding in it. So we understand that is the first, that is the solubility of the solid solute in liquid solvent, that we understand. All the points very easy to understand, but it is interesting that there is something that there are, what is, we understand what is solubility and what are the factors going to influence the solubility of this solute solvent. Okay, that is all for today's lecture. If you like this lecture, you can share to your friends. Thank you very much for watching.